Good morning, students. This is Shantini Datta. The topic that we'll discuss today is electrostatic. The topics that we'll discuss today: number 1, introduction, electric charge, type of charge, characteristics of charge, electron, proton, neutron, process of charging, point charge, mass and charge, Coulomb's law, relative permittivity of a medium. Electrostatic. The term electro means electron, static means rest. When electrons are at rest, it is known as electrostatic. Electrodynamics. When electrons are at motion, then it is electrodynamics. Example for electrodynamics is current AC. The example for electrostatic is electric field. The next topic is electric charge. What is a charge? Charge means it has certain physical property or it has some inherent property which causes it to experience a force when it is placed in an electromagnetic field. Or you can say it is the energy possessed by the body by virtue of which it will show attraction or repulsion when placed in an electromagnetic field. Symbol of the charge: you can denote a charge by capital Q or small q. Unit of charge: the SI unit is Coulomb, CGS unit is ESU, electrostatic unit or stat Coulomb. There are two types of charges: positive charge, negative charge. Similar charges repel each other, unlike charges attract each other. Characteristics of charges: number 1, intrinsic property; number 2, scalar property; number 3, conservation of charge; number 4, quantization of charge. These all properties we will discuss now. Intrinsic property: it is the property that an object has for itself. It is constant throughout the entire set over space and time. Scalar quantity. Scalar quantity means the quantity which has magnitude only but no direction. Charge is a scalar quantity. Charge has only magnitude but no direction. Law of conservation of charge. Charge can neither be created nor destroyed. It can only be transferred. Total charge of an isolated system remains constant. What do you mean by an isolated system? A system through the boundary of which the other systems cannot interact. The examples of conservation of charge: When a glass rod is rubbed with silk cloth gains electron and thus becomes negative, and glass rod loses electron and thus becomes positive. Thereby it is seen that the magnitude of the positive charge on the glass rod is equal to the magnitude of the negative charge on the silk cloth. Therefore, the total charge in the isolated system of the glass rod and the silk rod remains constant. Next example is when ebonite rod is rubbed with fur. When ebonite rod is rubbed with fur, the fur becomes positive and the ebonite rod becomes negative. The ebonite rod gains electron whereas the fur loses electron. It is seen that the magnitude of the positive charge on the fur is equal to the magnitude of the charge on the ebonite rod. Thereby the total system in the isolated system of the fur and the ebonite remains constant. Next example is a radioactive decay of uranium. When radioactive decay occurs, uranium produces thorium and an alpha particle. The atomic number of uranium is 92 and the atomic number of thorium plus alpha particle is equal to 90 plus 2, 92. Thereby the total charge remains constant. The next topic is quantization of charge. Charge always exists in integral multiple of fundamental charge. Q is equal to N into E, where the N is equal to the number of electrons and N is always an integer. E is the smallest charge which can exist independently, that is an electron, whose value is 1.6 into 10 to the power minus 19 coulomb. Q is equal to the charge on a body. Electron, proton and neutron. There are few data which you have to remember. That is the charge of an electron and charge of a proton, both are same, but proton is positive 1.6 into 10 to the power minus 19. Electron is negative minus 1.6 into 10 to the power minus 19. Neutron has no charge. Next, the mass of the proton is 1.67 into 10 to the power minus 27. Mass of an electron is 9.11 into 10 to the power minus 31. And the mass of the neutron is 1.67 into 10 to the power minus 27. So the next topic is process of charging. There are three ways by which charging can be done. Number one, friction. Number two, conduction. Number three, induction. Charging by friction. The process in which a body gets charged when it is rubbed against other body. Next, charging by conduction. The process in which a body gets charged by making contact with a charged body. There has to be a contact. Third, charging by induction. In this process, the body gets charged by a charged object without any contact. So in friction, what happens? Rubbing occurs. In conduction, what happens? There has to be a direct contact between a charged body and an uncharged body. Induction is that there should be one uncharged body, another is a charged body, but there is no contact. In friction, one must rub one material to another. What happens by rubbing is that there is a transfer of electrons. Wherever there is a gain of electron, that body becomes negatively charged. If a body loses an electron, that body becomes positively charged. But the magnitude of the positive charge body should be equal to the magnitude of the negative charge body. And there is, in a case, we can say there is a transfer of mass also. Very negligible, but yes, there is a transfer of mass because the electrons are getting transferred. The electrons have certain amount of mass, so that mass is also getting transferred. Charging by conduction. When an uncharged body is in contact with a charged body, the excess of electrons from the charged body is transferred to the uncharged body, and thus the uncharged body becomes charged. This process is known as conduction. So in conduction, if there is two body A and B, suppose body A has charge Q and body B has no charge. This is the initial condition when the body A has charge Q and the body B has zero charge. Now, if both the material, both the body A and B is of same shape, size and material, then if I make the two body come into contact by a wire or just come into contact both of the body, if I touch the both of the body, then what will happen after some time is that we'll find that body A and body B will have same amount of charge. That is, the total charge will be divided by 2. So the total charge the body A and B has is Q charge, because A has Q charge and B has zero charge. So the total charge of the body A and B together, it has charge Q. So finally, if both the bodies A and B come into contact, what will happen is that final stage is that the charge will be divided. So the total charge is Q, the charge will be divided into 2 for the both the bodies. So charge A finally will have Q2 by Q by 2 charge, and the B will also have Q by 2 charge. Charging by induction. Induction means that when a body is charged without in contact, without touching it, if I can charge a body without contact, then that is known as charging by induction. In induction, there won't be any direct contact between the charged and the uncharged body. So what happens over here is that if you want to make a body, uncharged body, which is a neutral body, if you want to make a neutral body positively charged, then what you will do, you will, as you can see in this diagram also, it is given in the first figure. If you see what is happening over here is that a negative charge body is brought near a neutral body, right? Now, if it is a negative charge body, it will attract the opposite charges. That is, the positive charges will be in the one side and the negative side will be another side. In this case, in this situation, what actually happens is that the electrons repel. The electrons of the neutral body goes from one side to another side. So the electrons actually travel. Protons don't travel. So electrons travel from one side to another side, and thereby there is a separation between the positive charges and the negative charges, which is known as to be polarized. So the body has become polarized. Now in this situation, what happens, the positive side is the one side, the positive charge is the one, and the negative, the charge is still, the body is neutral. Okay, because why it is neutral? Because the number of protons and the number of electrons are equal, so it's a neutral, it is not charged yet. Now what I do it is that if I take this neutral body and connect it with ground, okay, ground is known as ocean of electrons. So electrons will, what happen, always has a tendency to go to the ground. Okay, so once I connect this with the ground, what will happen is that the electrons in that side will flow to the ground. Okay, so all the excess electrons will go out. Now the electrons move out from the body, thereby once now the earthing is disconnected, now the body is now becomes a positively charged body. Point charge. Point charge is a concept which is used everywhere in physics, especially in electrostatic. It means that it does not have any dimension, it does not take up any space. So the next topic is the difference between mass and charge. Both mass and charge has some similarities. These similarities are like both mass and charge are scalar quantities. Scalar quantity means that it has only magnitude, no direction. Second is that both mass and charge are the intrinsic property of matter. Intrinsic property of matter means it is the property that the body has for itself. It is its own property. Next is that both in the case of mass and charge, the force that acts, that is the gravitational force for the mass and the electrostatic force for the charge, both of them obey the inverse square law of interaction. Next is that charge is a derived quantity and mass is a fundamental quantity. Next is that both exist, charge exists in positive and negative, and mass exists only in positive. Mass cannot be negative. Next is that the law of conservation of charge holds good, but in the case of mass, law of conservation of mass does not hold good. Mass plus energy is always constant or conserved. Next is charge is quantized. Quantized means that Q is equal to NE, that is the multiple of, it always, charge always exists in an integral multiple of fundamental charges, that is Q equal to N into E, where E is the smallest charge which can exist independently. Whereas mass is not quantized, or this quantized property is not yet clear to us. Next is that acceleration. Acceleration. Now the mass, when a mass is accelerated, it does not radiate any energy, whereas when charge is accelerated, it radiates energy. For example, you can see in this alpha rays, beta rays, it what happens due to the accelerated charge, particle emits energy or radiates energy. Next is that a very important point is that charge does not vary with velocity. It remains constant. Means the positive charge remains positive and the negative charge remains negative. The value of the charge remains same with the velocity. But mass vary with velocity. Mass vary with the velocity with the equation is m is equal to m naught divided by root over of 1 minus v square by c square, which is the relativistic theory, where m is the relativistic mass, m0 is the rest mass, and v is the velocity of the object, and c is the velocity of the light. Now what happens is that if a mass have certain amount of velocity which is comparable with the velocity of light, then the mass will vary. So if the velocity is near to light velocity, the velocity of the light, then only the mass will vary with velocity. So the next topic is Coulomb's law. Coulomb's law holds good for point charge. Point charge means the charge should be in small dimension with respect to distance. So a building can also be a point charge if I consider the building and another building is quite at a larger distance. For example, one building is in Calcutta, another building is in Delhi. So the distance between the two buildings are quite large. Therefore, we can consider that to be a point charge. So it holds good for a point charge. So with respect to distance, that has to look like a point. Depends on the nature of the intervening medium. It depends on the intervening medium. That means the charge, whatever the charge we are holding it, the force between the charge we are finding it, the medium between that charge depends on the nature of the medium. Whatever the nature of the medium is there, it depends on it. Next is that the force, the Coulomb's law, the force acts along the line joining the two charge. So in Coulomb's law, the force which acts that acts along the line joining the two charge, and thereby it is known as a central force. Central force. So first is that it holds good for a point charge. It's you cannot consider Coulomb's law for a charge distribution. It has to be a point charge. Second is that it depends on the nature of the medium we are between the charges. So whatever the medium is there in between the charge, it depends on it. If I take out the force of two charge when placed in the air, the force will be different. If the same charge, if I put it in the water, the force will be different. So it depends on the nature of the intervening medium. Next is that it acts along the line joining the two charge. The force has the direction, this direction is acts along the line joining between them, which shows that it is a central force. Okay, whenever the force is acting along the line joining between it, then that is a central force. Next is the conservative force. It's Coulomb's law, the force which it acts, that is the conservative force. What does a conservative force means? That it depends on the initial state and the final state. It does not depend on the path. So this force does not depend on the path. It depends on the final state and the initial state. Next is that this Coulomb's law obeys Newton's third law. That is the force exerted by second charge on the one will be equal to the force exerted by the first charge on the second. So F12 is equal to F21. So this, it obeys the Newton's second law. Next is that it is directly proportional to the product of the charges. So whatever the charge you're taking, that charge, it will be directly proportional to the product of the charges. Next is that inverse square law. That means the force is inversely proportional to the square of the distance. As you can see in this graph also, the inverse square graph is shown over here in this in your screen, you can see it. So the graph will be like force as you increase the distance. As you increase the distance, then what will happen? The relation between F and R is inverse square law. It follows like this. Next is that so the equation is F is equal to K into Q1 into Q2 divided by R square, where K is the constant, that is the value of 1 by 4 pi epsilon 0, that is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So we'll discuss about this permittivity in the next slides. So the definition of Coulomb's law will be that Coulomb's law states that the force of attraction or the repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So in the definition, what you have to remember, that you need to say that it is a point charge. You need to say that it is directly proportional to the product of the charges. And the third point is that it is inversely proportional to the square of the distance between them. In the definition also you can add that if the two similar charges comes, then the nature of the force will be repulsive, and if both the charges are in opposite in nature, then the nature of the force will be attractive in nature. Next, you can say also in the definition also you can say the points like the force will be central force, that it will act along the line joining between them. You can also say that it will be a conservative force, that means that it will depends on the initial state and the final state and will not depend on the path. And you can say that it depends on the nature of the medium. These are the points, you can write it down in the definition points. So the equation for the Coulomb's law will be F is equal to K into Q1 into Q2 divided by R square, where F is the force between the 2 point charges Q1 and Q2. Q1 is 1 point charge, Q2 is another point charge. R is the distance between the 2 point charges, and K is the constant, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Now in this is the formula, mathematical formula for the Coulomb's law. So the Coulomb's law states also that the closer the two charges, the stronger will be the force between them. If the distance between them is small, because distance and force is inversely proportional, if R is less, then F will be greater. The force experienced by the charge will be greater. Again, a sum comes like this in this same topic, that if the R, the distance between the 2 point charges, is being doubled, then what will be the force, the new force? If the distance between the 2 point charges is double, then the force will decrease by 4 times, because F is inversely proportional to distance, square of the distance. Again, if R is tripled, R means the distance between the 2 point charges is being tripled, then the force will be decreased by 9 times. F directly proportional to 1 by 3 square, that is F is equal to, will be decreased by 9 times. If I make the distance R into half, whatever the R was previously, if I make it R divide by 2, make the distance between the 2 point charges halved, then the force will increase by 4 times. If the distance between the 2 point charges is 1 by 3 times, then the force will increase by 9 times. So the relation is between F and R is equal to F is inversely proportional to square of the distance. The next topic is electrostatic force versus gravitational force. Electrostatic force, the equation for it is F is equal to K into Q1 into Q2 divided by R square, and gravitational force, the equation is F is equal to G m1 into m2 divided by R square. The similarities between these two forces are that number 1, both are central force. Number 2, both are conservative force. Number 3, both follows the inverse square law. Number 4, both can operate even in vacuum. These are the similarities. So the similarities is central force, conservative force, inverse square law, and can operate in vacuum. What are the differences between these two forces? Electrostatic force deals with the force between the two charges. Gravitational force, it deals with the force between the two mass. Electrostatic force, it can be attractive in nature as well as repulsive in nature, whereas gravitational force will always be attractive in nature. Electrostatic force depends on the medium, whereas the gravitational force does not depend on the medium. Next is that electrostatic force is a stronger force and gravitational force is a weaker force. Over here, the constant for the electrostatic force is K, which vary, whereas the constant for the gravitational force is capital G, which is universal constant. So the next topic is permittivity of medium. Permittivity means it is the property of the material. So epsilon 0 is known as the absolute permittivity of free space, and epsilon is the permittivity of the medium. When the charge is placed in any medium, if it is placed in free space, then the medium will be absolute permittivity of free space. If it is placed in any medium like water, ether medium, etc., then it is epsilon m, or the permittivity of medium. Permittivity is the property of the medium where the charge is being kept. Now, according to the Coulomb's law, F is equal to 1 divided by 4 pi epsilon 0 Q1 into Q2 divided by R square. So, the value of K, that is the constant, that is equal to 1 divided by 4 pi epsilon 0. So we can, by the equation, we can understand that force and epsilon 0 or epsilon is inversely proportional. If the medium has maximum value, the permittivity of the medium has a maximum value, then in that medium the charges will experience less force. So if the value of epsilon is greater, then the force that it will experience, that will be less. The minimum value is in air or free space. The value of epsilon is minimum in air or free space. Air, the value is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Epsilon 0 is always minimum in free space, thereby the force experienced in the free space will always be maximum. Whatever charge you take, if the charge is kept in the free space, that will experience the maximum force in the free space or air. The same charge, if you keep it in water, it will experience less amount of force, because epsilon 0 is minimum in the case for free space or air. So the force experienced by any two charges placed in air or free space or vacuum is always maximum. Since epsilon 0 is less than the epsilon, therefore F naught, that is the force experienced in the air, is always greater than the force experienced in any medium. Permittivity. Permittivity describes how an electric field affects and is affected by dielectric material or medium. It relates to the ability of a material to transmit an electric field. Each material has a unique value of permittivity. Permittivity of free space, it is 8.85 into 10 to the power minus 12 farad per meter or Coulomb square per Newton meter square. The formula for the relative permittivity is, it is the ratio of the absolute permittivity of the medium to the vacuum. That is, epsilon r is equal to epsilon divided by epsilon naught. Thank you.